Hey everyone, welcome back to the channel. And today we'll be getting started with Kubernetes. So if you're someone who is, start thinking of starting learning Kubernetes, then this video is for you, because we'll be deep diving a bit in Kubernetes cluster architecture. It's going to be entirely beginner friendly. So, and I'll try to break down terms as much as I can. So maybe it would help you to understand concepts a bit better. A bit of fair warning, or I would say a prerequisite before watching this video, would be to understand containers. If you want to, then I have a separate video over what containers are and how is it different from virtualization and all that. It is compiled in my Docker video, getting started with Docker video, and it is uploaded on my channel, this channel itself. So if you want to, then you can check that out, or any other resource. But it's vital that you should know what containers are, because Kubernetes is a container orchestration tool. So if you don't know what containers are, then you won't know how to orchestrate them. I think that makes quite a bit of sense. So do make sure to watch my Docker video or any other resource that you find learning comfortable from. So let's just start with the video. So what is Kubernetes? So when I'm talking about Kubernetes, as I just said, Kubernetes is a container orchestration tool. So before we jump into the crux of the cluster and all that, let's just understand container orchestration. So obviously we know about container from our Docker video. We know what containers are. Let's just understand what orchestration is. Okay, so basically orchestration, we can say, let's just say our application is running on containers, and let's say we have made a huge application and parts of it are made as containers. So I as a user would want that these containers are deployed on a right system and they are working together in harmonious way. So obviously I would want that. So Kubernetes does that job for me. Kubernetes keep an eye on my containers. It makes sure they are running fine and they are running on the right system. They are always running, like, they make sure if one of my containers goes down, it makes sure to take necessary steps to make sure it doesn't come to a stage when my whole application fails. So it takes necessary steps for that. So it makes sure that my application is deployed in a reliable way and we can scale it anytime we want. So it helps us to orchestrate all these containers. It's like a traffic policeman. It ensures that everything is going the right way, and everyone is working in a harmonious way. And in this case, these are containers. So I think you got a bit of knowledge about what container orchestration means. Containers are obviously managed by Docker. We create containers of our applications, and in order to make sure that they are working in our desired way, the way I want them to run, Kubernetes helps me to achieve that. So let's just dive deep into what Kubernetes cluster looks like. Okay, so let me just share my screen here. Okay, so I hope my screen is being shared, because that'd be a disaster if it isn't. Okay, so here we have our Excalibur opened up, and this box, I hope it demonstrate a cluster architecture. So basically it's a cluster. Let's say it is this box, it's a cluster. Okay, now in this cluster we have two main things. We have a master node and then we have a worker node. Now worker nodes can be deployed on cloud or in person or anywhere. Okay, so they can be deployed anywhere, but master nodes, basically, as the name suggests, they are master. They are looking over the worker nodes. So master node ensures that worker nodes are working fine, that there's nothing going wrong with the worker nodes. So it overlooks the worker nodes, as the name suggests, master nodes. So let's just quickly create two nodes. This is the master node. Let's just label this ASAP master node, just so we are clear. Cool. This is master node, and then we can create a worker node. Now worker node, I am going to only specify, I'm going to only make one. Oh, they are not that small. Okay, so I'm going to make only one worker node, but make sure, no, keep that in mind that worker nodes can be multiple. It doesn't need to be only one. You can create multiple work nodes. Here, just to demonstrate, I'm creating a single work node. This is a worker node. Cool. Now, okay, so we got to know we have a master node and worker node in a Kubernetes cluster. Now, this master node on the left hand side, it has some Kubernetes objects that make every possible procedure in Kubernetes possible. Same with the worker node. Worker node itself has some Kubernetes objects that communicate with objects of master node to make our, the processes, the orchestration of containers possible. So let's dive into what master node has, what all Kubernetes object master node holds, and then we'll talk about what all Kubernetes objects worker node holds. So basically, we can talk about there are 6 main Kubernetes objects. 4 of them are in master node and 2 of them are in worker node. We're just talking about main stuff. So master node, if we talk about, let's just create 4 blocks first. We can just paste it. So we don't have to draw it all over again and again and again. Okay, cool. So now we have 4 objects in our master node. Cool. Oh, we already had one. Okay. Let me just name all these nodes, all these objects. I'm sorry, my bad. So let's say you don't need to know any of these that I'm mentioning right now. I'm going to explain each and every single the Kubernetes object. So one of these objects is called etcd cluster. We call it etcd cluster. I myself had quite a trouble, pronouncing this. Well, first time I started learning. So we have etcd cluster. Then we have kube API server. Kube API server. Okay. E is missing. I think that doesn't. It's okay. I think. Then we have kube controller manager. Controller manager. By the way, if you are following me on Twitter, you would know that I was preparing for Certified Kubernetes Administrator exam. That is one of the certifications that you can get for your to acknowledge your specification Kubernetes, that you have quite a good knowledge of Kubernetes. The reason I'm discussing this right now is because, as you can see here, my notes for CKA are here. So if you want to, if you're preparing for CKA, if you want to just revise, if you're watching just for revision, then I would like for you to check this out. I have shared this multiple times on my Twitter handle. So if you want to, then you can check that out. I'll also be sharing the link down below this video. So if you want to check these notes out, then yeah, sure. I've created tags so that it is easily to, maneuver through these notes. So yeah, just a quick glance at the nodes. Okay, so moving on, we have etcd cluster, we have kube API server, we have kube controller manager, and what we are missing? We have oh yeah, okay. So we are missing. Let me just create for worker nodes too. Worker node, cool. Okay, kube proxy, kube controller manager. What are we missing? I keep forgetting the name. Okay, let's just give I can also forget stuff. Kube scheduler. Okay, it's a really amazing object. I'll be discussing about this too. Kube scheduler. Okay, so we have kube scheduler, etcd cluster, kube API server, and kube controller manager. Now these are 4 objects that come under master node, and in worker node we have kubelet and kubeproxy. Okay, so we have six. Oh, we have 6 in total, 6 Kubernetes objects in total. And yeah, let's just discuss about each each and every object in detail. But before we do that, just a quick fact that I want to get you familiar with. So as you guys know, if you watch my previous video, you know all about Docker and containers and all that, right? So there was one thing that was going on. The fact was Docker was created way before Kubernetes was created. Now Kubernetes was created by Google. Okay, it was originally created by Google. So we had Docker, right? We had Docker. Excuse my writing because I'm doing this via touchpad, so I think it's a bit big. Okay, so we have Docker. Okay, we had it way before Kubernetes. Now Kubernetes came after Docker. Okay, Kubernetes came after Docker. And the sole purpose the Kubernetes was first made was to manage Docker. Docker had its Docker has the ability to create containers, and Kubernetes was first formed to manage Docker entirely. It wasn't made for any other container runtimes or tool, but it was created just for Docker. Now the thing was, as the popularity of Kubernetes increased, as it became more and more popular, different container runtime tools, such as, if you've heard of Rocket, there's one called Rocket. Now Rocket, obviously it said like, I also want it to be, I also want my containers to be managed with Kubernetes. I also want to use Kubernetes. Now it became a problem. Why? Because as it was created before, it was created only for Docker, it didn't have the power to manage other container runtime tools. So what it did is, Kubernetes, what it did is, it started a container runtime initiative, CRI. We call it Container Runtime Initiative. Now, according to this initiative, only those container runtime tools that follow a rule laid by CRI. So not to make you, not to have any confusion, let's just start all over again. I know it can be a bit confusing. It was for me. I don't want to make it confusing for you. So Docker was first created way before Kubernetes was created. Now Kubernetes was created solely to help Docker. Okay, it was created solely to manage Docker. Now as Kubernetes popularity grew, other container runtime tools such as Rocket wanted to get involved with Kubernetes, obviously. So basically, now in order to manage other container runtime tools, it laid out container runtime interface, which in turn lays out a rule called OCI. What is OCI? OCI means Open Container Initiative. Now it is a set of rules that has 2 rules under it, if I'm correct. One is called image spec, that is image specification. Image. Okay, let's just do IMG, and runtime spec. Okay, runtime. It's quite difficult to write with touchpad. So it had 2 rules: image specification, runtime specification. Okay, so CRI laid out a rule called Open Container Initiative, which had 2 rules in it called image specification, runtime specification. Now, if a container runtime tool is following these or is following OCI, then and only then it can be used with Kubernetes. I think that's pretty clear, right? Now, there comes a twist in the story. What's the twist? Now, as I said, Docker came way, way, way before Kubernetes came. Not that way, way, way before, but it came way before Kubernetes was created. So obviously, Docker was not following OCI. Now, why would it? Because it didn't even know that this kind of stuff is going to happen in future. So it was not following OCI. But we needed, as Kubernetes was solely created for Docker, and most of the folks were using Kubernetes along with Docker along with Kubernetes at the time. They couldn't just shut off their use of Docker. So what they did is they said, okay, for Docker, just for Docker, we are going to start a new service. And that new service they called Docker Shim. Docker DockerShim, just for Docker. Now this service was created just for Docker. Now, for quite a while, it was going pretty good. Okay, we had every other new container runtime that wanted to get involved with Kubernetes. They had to follow OCI. But for Docker, we were using Docker Shim. But obviously, if you are, having an entirely new service just for one container runtime, it's going to be a hassle to maintain it, right? Obviously, so it was a hassle to maintain Docker Shim just for Docker. So what Kubernetes did was it had to take a strong step. And after Kubernetes version 1.24, what it did was it finished or it's shut down the use of Docker Shim. Now, when as Docker Shim was shut down, you could no longer use Docker with Kubernetes. Now that's a problem, right? Because many companies were using Docker with Kubernetes, so it was going to be a problem for them. No, it was not, because Docker images, the images we create of our applications, these images were following one of the OCI rules, image specification. Although it wasn't following runtime, but it was still following the image specification. So only Docker images you can now use Docker images with Kubernetes. So the people who were working already with Docker, they could continue their work with Docker. So they didn't need to, change the container runtime altogether. So I think that was a close call, but it worked out at the end. But Docker had a component called as container D. Container D. I think most of you, if you're in the cloud native space, you must have heard of container D. So Docker had a component called container D. Now container D followed CRI. It followed container runtime initiative. So container runtime started working as its own tool slowly and slowly as it got separated from Docker, because it was following CRI, but Docker wasn't. So it kind of separated, container runtime separated from Docker. And it's now, if you take a look, it's a project of its own. Container D, it's a whole project on its own. Container, my writing is really bad. So we have container D. Okay, so we have container D, and I'm glad to tell you that container D is a CNCF graduate project as of now. So yeah, you can go ahead and contribute to it. And how you can contribute to it, because it's open source. Kubernetes is also an open source tool. So if you want to go ahead and contribute to Kubernetes or container D, then just go ahead. And if you would like to know how you can contribute to Kubernetes or containerd effectively, then I have a video for that too on the channel. In fact, it's my very first video that I created, so where I have laid out some points how you can effectively contribute to open source. So maybe you can take a look, and if those points can help you out, then I think it's a win-win situation for both of us. So yeah, let me write. It is a CNCF. I'm just gonna write G. I ain't gonna write graduated. So it's a CNCF graduated project. So I think it makes stuff a bit clear, although I've made a mess of all this, but I think you got the idea of what happened with Docker, containerd, Kubernetes. and how they are working together now. So Docker and Kubernetes, how they're working together. Okay. Enough talk about Docker. It's not a video about Docker. Let's just go back to where we were. We were on cluster. Oh, this looks so beautiful in comparison to the one mess I made down below. Okay. Let's just go back. Okay, cool. Okay. So we have masternode. Masternode have 4 Kubernetes objects: etcd cluster, kube API server, and kube controller manager. So etcd cluster, basically what etcd cluster is, etcd cluster holds the info about, let me just decrease the opacity. Okay, so etcd cluster, what is etcd cluster is doing is, etcd cluster is storing, this is the cluster, right? Etcd cluster is storing the information about the entire cluster. Now if I want to ask anything from the etcd cluster, now let me give you an example real quick. So I have my terminal open here. Let me start a local Kubernetes cluster. I'm using Minikube here. You can use K3s, kind, anything. So let me just start this real quick. So I hope you guys are getting to learn this. Like, I'm hoping you're understanding everything. So let me just show it real quick. It takes a bit of time to start a local Kubernetes cluster via Minikube. If you're going to use kind, I think it starts up your cluster real quick. But I find Minikube much better because I've been working with it for a while now. So, okay. As you can see, it's preparing the Kubernetes version on Docker. Again, okay, let's just go back. It's taking a bit of time. So etcd cluster, what it does is etcd cluster holds the information about the entire cluster, and that is exactly what etcd. Oh, there we go. Cool. So just to take a look, if everything is working fine, I'm going to check Minikube status by Minikube status command if everything is working fine. So as you can see, everything is running. Now, whenever if you're quite a bit familiar with Kubernetes, we communicate with Kubernetes via kubecontrol, right? Kubecontrol is a command line tool for Kubernetes. So I'm going to say spelling mistake. So kubecontrol get ports. Now this is a really basic. Now I'm going to explain what. Let's just remove ports. I was going to explain what ports was, but let's just go with nodes because we have talked about nodes. So whenever we do kubecontrol get this, kubecontrol create, kubecontrol run any command. Now if I do this, now what it did is, for us it gave us this. Now, but where did this information come from? It came from etcd cluster. The etcd cluster residing in our Kubernetes cluster gave me this. When I asked, hey, give me what are all the nodes that are running on my Kubernetes cluster, it said, hey, Minikube is running on your Kubernetes cluster. This information was provided to me by the etcd cluster. So etcd cluster does this job. Whatever I'm asking, etcd cluster provides. But it doesn't just provide this straight away. There is a process. There are a series of steps it follows. We're going to check that out too real quick. Kube API server. I'm glad it came right now because we are discussing about etcd cluster. So Kube API server, what it does is, Kube API server, it's a gateway to Kubernetes cluster. Okay, it acts as a gateway to the etcd cluster. Basically, as I am using kubecontrol, as a user, I'm using kubecontrol in order to communicate with my Kubernetes cluster. Now, any information or anything that I require on the cluster, I send the request through Kube API server, and the Kube API server in turn sends the request to etcd cluster. Now you might be wondering, why can't we send the request straight away to etcd cluster? Why do we need to go through Kube API server, and then the Kube API server has to send the request to etcd cluster? Well, there's a reason for that too, because Kube API server follows a series of steps, as I said before, and those series of steps are necessary in order to ensure that the information that is being accessed is being accessed by a verified user. Now, I've already made these 7 steps, so I don't have to write them and waste our time. So basically, first of all, when I'm sending a request, I send kube control get nodes. Now, for us, it just came out instantly, but that's not happening internally. What's happening is when I said kube control, hey, kube control, get me what all nodes are running on this cluster. So first it does is it authenticates the user. Now, as I am a local user and it's set up locally, it's not, it knows that I am the person who can access, I am having the admin access, so it doesn't authenticate it, like it doesn't need to authenticate it that much. But if you're working in a professional or production environment, then it does authenticate it if you have that privileges or access to that information or not. Well, we won't be discussing it right now. It comes under Kubernetes security. And if you want to learn about Kubernetes security in detail, then I and Sid have already, we went live a few weeks back and we discussed about Kubernetes security, TLS certificates, and all that. So if you want to check that out, that video is also available in the live stream section of this channel. So if you want to check that out, then you can. So yeah, I always, derail from the topic. Okay, so it authenticates the user as I'm the local user. It knows that I'm the admin. Then it checks, it validates the request if I am sending a correct command or not. It checks if I'm not just, let's say I am doing kubectl and get nodes. Obviously, it's not a command. Or well, that's not the. Let's just say kubectl get nodes. Okay, it says the server doesn't have a resource type nodes. It validated my request and it said there's nothing, no a resource like nodes. So validated my request, kubectl get nodes des1. It's the right one. So it just send that request to the etcd cluster to retrieve the data. Then update etcd comes under, let's just say I'm deploying a new pod. Let me just deploy a pod real quick. So kubectl run nginx. I'm running an nginx server and I'm providing an image of nginx. Okay, I think everything looks good. Yep. So there we go. Pod is created. Now if I'm saying kubectl get pods in order to check if it's running or not. Oh, I did a spelling mistake. I'm sorry. There we go. It's running, right? Kube control get pods is running. Now what it did is the pod wasn't there before I created. There were no pods before I created one. Now what it did is it authenticated me. Yes, I'm the user. Then validated the request. It retrieved the data. And now what it did is I sent the kube control get pods. The pod was created. Now etcd, in etcd storage, there were no pods. But now a pod was created. So I'm updating my etcd cluster to make sure that etcd knows that a new pod has been created and to store that information in etcd in itself, so that whenever I access kubectl get pods, it would give me, yes, this pod is running. Because if I don't update the etcd cluster, it won't know any pods are running or not. It would always show me that there are no pods running. So it basically updates the etcd cluster. It then schedules it. How it is getting scheduled? It is scheduled by the help of kube scheduler. Will let's just jump in. I don't think it's a massive topic, kube scheduler. So scheduler is done by kube scheduler. Okay, kube scheduler is the one that helps in scheduling our containers, our deployed applications that are containers in this case, on the desired port. Now, why are you saying on desired port? It can run on any port, right, Shivang? No, it cannot. What if my application, what if my container has some hardware constraints, some resource requests, some resource limits? I want to limit the resource usage for this container, so I just can't just deploy it on any of the ports. I'm going to limit that port to run on a node that I want to. So let's just say I have a container that I don't want it to, use. Let's just say 1 GB. I'm giving it. It should run on at least 1 GB, and it should not cross the limit of 2 GB. So it can use up to 1 GB or 2 GB, but it cannot cross that threshold. So basically I'm putting up a constraint on this. I'm putting up a constraint. So kube scheduler schedules the pods or containers according to my desires, according to restraints that I'm putting. So that is scheduler. And then kubelet. Now why I'm saying kubelet? Because I'm accessing it via kube control. Kubelet. Oh, let's just, because kubelet comes under worker nodes, I wasn't sure if we should discuss it, but yeah, let's go. So kubelet, basically you can talk to the HCD or HCD. You can talk to the Kubernetes cluster via kube control. And how you can talk via kube control? By sending the request via kube API server, and kube API server will then talk to HCD cluster to fetch the required information that I want to access. So these are the series of steps that goes under kube API server. So yeah, this is it. Now kube controller manager is another great topic, but let's just finish it because this requires some time. Kube controller manager, I don't want to rush with it. Let's just focus on worker nodes. ASAP kubelet, again, as I just said. Kube controller, kube control, we use kube control to talk to Kubernetes cluster via kube API server, which then fetches our request or data from the HCD cluster. Now kube proxy, well, kubeproxy, we do have some services that run on our Kubernetes cluster if we want to configure them. And these services are running on different ports or containers, these services. Now kube proxy helps us to communicate between different services that are running on different ports. So if a pod is having a node pod or cluster IP, let's just not dive deep into it. I'm going to explain it a bit in detail moving forward in this video, but it basically helps us to communicate with other services in the cluster. So kube proxy does that for us. Now kube controller manager. Now kube controller manager, it is the component of a control plane. Okay, it is a component of control plane that manages controllers. Now what are controllers, you might ask? Hey Shivang, what is controller, what are controllers? So I should have made it, but it's okay. So Kubernetes controllers, we have Kubernetes controllers. Let's just, there are 4 types of Kubernetes controllers. Okay, the first one, let's make 4 arrows, ASAP. There we go. There we go. And there we go. Cool. The first comes, so kube controller manager manages Kubernetes controllers, and there are 4 types of controllers called as. First is replica set. Replica set. Before we jump into replica set, let me tell you what pods are, because I've been talking about pods for so long. I think you might not have an idea of what pods are. Now, let me put this aside for now. Let's just remove the, we can keep this. We can just remove, let's just forget about kubelet and kube proxy were there, because I don't want to, make it a mess over here. So in our nodes, the smallest unit of a Kubernetes cluster are pods. You cannot create anything smaller than that. We have a cluster, and the cluster we have a master node and worker nodes, and in our nodes we have our pods running. So in this pod we have our pod, and we can have multiple pods running. Okay, you can create up to 10 pods, 11 pods, any number of pods that you want in a node. Okay, let's just say we have 5 pods running, and in these 5 pods we can have containers. We can have our containers. Now these containers can be different parts of our application that we want to, so that we want that they should work harmoniously, and in we want that if one of them goes down, then there are certain steps that Kubernetes should take. This is Kubernetes cluster container orchestration that it keeps in mind. Okay, that is what Kubernetes helps us in achieving. So these are all ports. Now there's nothing smaller than that, and our containers are running on these ports. The containers we create, if you have watched our Docker video, my Docker video, then you know what containers are. and that is why a prerequisite for this video was containers. So these containers live on these pods. Okay, so now we know what uh, these are. Okay, replica set. Now replica set is a Kubernetes controller. Okay, now replica set ensures. Now let's just not jump into Kubernetes. Replica set, Kubernetes controller, and all that. What is the let's just discuss what is the role of these Kubernetes controllers. So these Kubernetes controllers ensure that desired state of our cluster is maintained. Okay, like I have 5 pods running on this worker node. Now its job is to make sure that these 5 pods are running on this node every time. Okay, not one of the pod malfunctions and nothing goes wrong with our cluster. Now this is the duty of a Kubernetes controller. They oversee our Kubernetes cluster and make sure the desired state is maintained at all times. So what is replica set? Now let's talk about replica set. It's been a while, we have written it over here, we haven't discussed it. So what is replica set? As the name suggests, replica set, uh, when we create our application, okay, replica set, we can create replicas of a pod. Okay, let's just make sure there's a we have a container C1 running. Let's just say C1 container is running on this pod. So what we can do is we can create replicas of this pod. Let's just say we have C1. Okay, okay, cool. Now these won't be running. Well, they'll be running, but at the time, like if we are accessing our application, then only the request will be sent to this port. Our request won't be sent to these other two containers, because this is our primary port for now. But let's just say in case our port, for any reason, it shuts down, it falls off, it's not running. Okay, so what to do? Because people who are viewing our site or our application, they want it to keep running at all times, right? So they are accessing this pod, but it is not giving any response. So that is when replica set comes into play. Replica set creates replicas for the ports. Like we have 3 or 2 replicas that are going to keep running at all times. So when one of them falls down, the other replica comes back up instantly, so that it there's no there's no downtime in accessing our application. So it just, another one of our application comes back up, a pod comes back up instantly when one of the primary pods fall down. And if this pod falls down again, then we have another pod, and you'll see, what if the third pod fails? What then? Then we always have 2 replicas running at all times. We always have 2 replicas. So if this is running, another one of the replicas is going to come. So we have 2 replicas always running on our Kubernetes cluster. Okay, so I think we are a bit clear on what replica set is all about. Make sure, because I'm still learning, again, I'm not an industry expert. I'm trying to provide any value, anything that I'm learning through this channel. So if I'm explaining something wrong, and if you think that I have explained this wrong, then go ahead and correct me down in the channel below. I love criticism, positive one. So if you think that I can improve upon this and that, then make sure to comment down below this video. So we have replica set. Okay, cool. Now we have deployment. Yep, we have deployments. Cool, we have deployments. Deployments. Okay. Now what are deployments? Now we don't need to create replica set like separately. Deployments manages replica sets. Like, you can include the number of replicas you want in the deployment itself, so you don't need to create a replica set file, manifest file. You can declare the number of replicas you want in the deployment file only. Now, what is deployment? Deployment takes care of upgradation, downgrading, rollback, rolling update, and all these things. Now, what are these upgrading, downgrading? Now, let's just forget about this. Let's just say we have this port and this port. We have these three ports. uh, okay, so now we got a new version for our application. Okay, the developer who made the application, he put out a new version. Now, what do we want as a consumer, at the end user? Like, we don't want downtime, right? Obviously, we don't want key all of the, like, let's just say my app is running here, here, and here. Okay, now I don't want that all of the container pods go down all of a sudden, right? In order to upgrade, because that would lead in a massive downtime, and we don't know like how much time they'll be back up. So deployment have this strategy called as rolling update, in which what happens is the previous version pod goes back down, but the other two keeps running, so that our application is accessible to the users at all times. So it goes down, and the updated one comes back up. Then the second one goes down, then an updated one comes back up. Third one goes down, then third one comes back up. So upgraded. Okay, it comes back up after being upgraded. So ensures that at all times my ports are running, my application is available to the end users. So rolling update means, again, it doesn't, like, if I have ports, five, let's say five ports, I don't want all five ports to go down while it is being upgraded. I want to access the application at all times. So what happens is, the first one goes down, and only after it comes back up, the second one goes down. It won't go down unless and until the first one is back up. So then the second one will go down. Then after the second one comes back up, then the third one will go down. Then when the third one comes up, then the fourth, and so on till the fifth. So this is the rolling update. That is a strategy with deployments. You can do a rollback. What is rollback? Again, that what if like, after my all the upgradations are done via rolling update, I sense a, oh, there's an error in this, I have upgraded this version, but I sense there's a problem with the new version. So with rollback, you can go to the previous version of the application, and you can, let users not experience any downtime. So basically, that helps with deployments. Then we have stateful set. I don't think we need to dive deep into stateful set, but just to, keep it clear, stateful set helps in stateful applications. Basically, it helps to create unique. It makes like, they are ordered. It may helps the stateful set helps that the uh, applications are ordered correctly and are in a unique way, are presented in a really unique way, and it helps with the stateful applications. So with daemon set, we can say, what is daemon set? Now, daemon set is a really amazing feature that I like personally. Daemon set. Okay. Daemon set. Okay, so we have daemon set. Now, what daemon set does is, it, like, let's say we have five nodes running, or any number of nodes running. Okay, so daemon set ensures that a pod, that is, like, let's just say we have a really important pod that we want that it always keeps on running. What if, like, the replica set was doing was that in worker node we had these replicas, number of replicas. Now, what if this entire node goes down? What to do then, because we don't have replica set for nodes, right? So daemon said, what it does is, let's say we have uh, another worker node here and another worker node here. Let's just say we have three worker nodes. Okay, now let's just say we have this pod running. So what the daemon set does is it makes sure that the pod that we want, like it's an import that we deem that it's quite important, what we are going to do, the copy of that pod is going to run on every single node in the cluster, so that if our node fails, then we have our application running at all times. Okay, so like let's just say our entire node went down, you cannot access this node at all. So what it will do, it will redirect its request to the port that is in the another node, another worker node. And then what if this one fails too, then obviously it will redirect its request to the port on the other worker node. So this is what daemon set does. Okay, so we have discussed Kubernetes cluster. We have master node, we have worker node. Master node governs other worker nodes. We have Kubernetes objects such as etcd, cluster, kube API server, kube control magic, kube scheduler. In worker node, we have kubelet and kube proxy. I think you've got a pretty good idea what happened with Docker and Kubernetes and containerd, what's going on with that. I hope you've got an idea of Kubernetes controllers. Let's just take a look at nodes. These nodes, just for get everything clear, these are prepared by me myself. You won't find these nodes anywhere. So I think it's just fair so that we can take a look if we haven't missed anything. Yeah, these are just plain text. I hope that you guys got a pretty good understanding of what these are. Yeah, we can discuss about services. Now, services, what are services? I have a pretty good image here just to explain. Well, this is just for notepad, but we are going to explain what services are, what kube proxy handles. What we were talking about kube proxy. So there are three different types of services in if you're learning about services in Kubernetes. There are three different types of services. First is notepad, as you can see from here. Notepad, let's just change this. Okay, so we have notepad, as you can see from here. We have cluster IP, and then we have load balancer. Let's take a look at what notepad is. Now, what notepad does is, here we have a node, and in our pod we have a container running, as I said. Okay, let's just go with, it's pretty big. Okay, so we have a port running in our container, obviously, and there's an internal IP assigned to our port. Now, how do I know this? I think we have a port running. Let's just say what is the IP of this. So if you do kube control get ports dash or wide, you'll get the IP attached to this port. Okay, cool. I think that's pretty cool. So now we have the IP attached. We have the target port. Now what it does is service node port. It assigns a port number to the service. That port number is in range of 30,000 to 32,767. So it assigns a port in between this range, any port. As you can see, in this case is 30,008, I believe. Yeah, it's 30,008. So it has assigned this port number to this service. Now any traffic that is coming to this port number will redirect it to our container. So if I'm sending a request, if I'm sending any traffic, like traffic is, if I'm sending a request to this port number, it will redirect it to this container. I'll be able to access whatever is going on this application. So that is what notepad does. I think you are clear on what I was saying. So just to give you a quick sum up, what notepad does is it assigns a port number to our service, notepad, our service. It provides a port number to our service, and the port number comes in the range of 30,000 to 32,767. In this case, as you can see, we have provided a port number of 30,008, and any traffic that comes to this port number redirects the we are able to access the content that is going on in our container. Now, what is cluster IP? Now, cluster IP is the default service that is running on our Kubernetes cluster. Now, what is cluster IP? Cluster IP gives an internal IP address. This is internal IP address. And as you can see kube control, oh sorry, kube control get services. Oh, my bad. Kube control get services. You can see cluster IP is the default as of now. I can change it if I want to. I can change it. So as you can see, cluster IP is the default. Why is it default? Because what it does is it provides an internal IP address to my container. Okay, it will provide an internal IP address to this. And if we have other nodes, let's just say this is one node, right? Let's just say I have another node here and another node here. Okay, and I have a container running here, pod basically, and inside pod we have containers. So if I'm having these pods, let's just say exactly this pod is running, not exactly, but pods like these are running on other nodes. So cluster IP assigns an internal IP address to a container, to a pod, and that container is accessible to other containers in the Kubernetes cluster, not on a different cluster, but in my own cluster. The number of containers that are running in any number of nodes, in any number of ports, all the containers can access that container via that internal IP address. So it basically exposes that internal IP address to other containers in the cluster. That's why we have the default service as the cluster IP. The third and the last service that we have is the load balancer. Now with the load balancer, what happens is basically it also provides a IP address, but this time it's an external IP address. Now instead of providing a port number, it provides our service with an external IP address. Now imagine an external IP address. Now imagine an external IP address being over here. Now what will that external IP address do? Again, all the traffic that is coming to that external IP will be able to access my container. Anyone who has a hold of that external IP can access my application and my container, the application running in my container. So basically, node port provides a port number, load balancer provides an external IP address, and cluster IP provides an internal IP address for the internal communication of the containers inside a Kubernetes cluster. So node port is not used in the professional atmosphere because it is not safe. It is not ethically safe. But load balancers are used professionally in a production environment. And as you might have heard, there are several services in AWS, also AWS load balancer and stuff. If you want to work with load balancers, you can also change this service right here to from cluster IP to node port if you want to work with that. And yeah, that's pretty much it. I think now this is a beginner friendly Kubernetes tutorial. I don't want to deep dive into other stuff. It's not like I won't be touching Kubernetes. We'll be doing live streams in the future, not as of now, about Kubernetes security, Kubernetes networking, Kubernetes storage, and all that stuff. But just to give you a start, just to give you a boost, I have created this beginner friendly Kubernetes cluster architecture. I hope it was beginner friendly. If something wasn't clear, then do tell me down in the comment section. I tried to explain it as easily as possible. But yeah, do tell me if you understood the concepts well or not. And also, again, you can access, if you're preparing for CKA or if you're doing some stuff, then obviously do check out the notes that I prepared for the Certified Kubernetes Administrator exam. And if you're appearing for the same, yeah, do tell me, then we can prepare it together. And yeah, the next video I'm planning is of explaining, as you might have seen, I put up a podcast with Dayan on what Armada is all about, because most of the folks were interested about learning about Armada and how they can contribute towards it. So I prepared that podcast with Dayan. I had an amazing conversation, as you could tell from the video itself. And then I'll be creating, and the next video I'll be creating is going to be about my Google Summer of Code project, like what was the end project all about and how you can set up that and work with that. So yeah, I think that's about it about Kubernetes. Also, again, if you didn't understand it because you don't know about containers and all that, then I highly recommend you to check out my videos on Docker. And if you want to contribute to open source projects that's Containerd and Kubernetes, then do check out my video on how you can contribute to open source effectively. And yeah, I think that sums up this video, and I'll see you in the next one. Till then, bye bye.